Good day, everyone. Our topic for today is all about solving problems involving sequence, arithmetic, geometric, harmonic, and Fibonacci. The writers are Sir Norman L. Santos and Mom Jennifer Grace Castro. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. And now let's proceed to our main topic, which is all about solving problems involving sequence. So before anything else, let's have first a review of the following formula that we will be gonna use in solving problems. The first one is the arithmetic sequence. In solving the nth term in the arithmetic sequence, we have this formula: a sub n equals a sub 1 plus quantity n minus 1 times d. For the sum of the terms, we have s sub n equals n quantity a sub 1 plus a sub n over 2. For the geometric sequence, we have the formula a sub n equals a sub 1 times r raised to n minus 1. Alright, so let's have the first problem. Alvin saved 1,000 in the first year. In each succeeding year, he saves 500 more than in the first year, or first year before. How much will he save at the end of 10 years? So let's make a representation first for this problem. So for the first year, Alvin saves 1,000. For the second year, it's 1,500. It has a gap of 500 pesos. For the third year, he saves another 500. So it also has a gap of 500. And so on until the 10th year. So we will use the formula since we are looking for the nth term. We will use the formula for the arithmetic sequence a sub n equals a sub 1 plus quantity n minus 1 times d. Why we use this formula? Because as we look to the gap, yung gap nila is 500. That is their common ratio, no? Meron silang tigpa 500. Okay? So, it means na nag-a-add lang tayo ng 500. Usually kasi, kapag geometric sequence yan, we multiply numbers. Pero sa arithmetic, parang nag-a-add lang. Okay? Nag-a-add or nagma-minus lang tayo. Nadadagdagan yung second term, third term ng similar number. So, as you can see, dito sa first and second, nadagdagan siya ng 500. So, sa third, nadagdagan ng 500. So, meron silang similarity. Okay, na nadadagdagan lang sila ng 500 or nag-a-add lang tayo ng 500. Okay, for the given, we have a sub 1, and that is 1,000. A sub 1 will be the first term. Now, if you want to remember the, what they call this, if you still remember the arithmetic sequence, right, that a sub 1 is the first term. So the first term is 1,000. For the d, we have 500. That is the difference of our terms. And then for the n, we have 10 because we are looking for the 10th year, right? In the problem, we're looking for the 10th year. Am I right? So, and we're looking for the a sub n. So now, solve for the money saved at the end of 10th year. So here are the given, and here is the solution. For the solution, as you can see, this is the formula that we used, and we will substitute the given to the formula. So 10 minus 1 is 9. 9 times 500 is 4,500 plus 1,000 is 5,500. So the money that Alvin saved at the 10th year is 5,500. Okay? That is the money that he will save. That is not the total. Okay? That's not the total. Hindi yun yung total ng pera. Yun yung pera na ihuhulog niya or isa-save niya, na kailangan niyang i-save. Kasi di ba every year nagdadagdag siya ng 500. So yun yung pera na kailangan niyang ma-save in the 10th year. Okay? But that is not the total. Hindi yun yung total na from first year to 10th year. Hindi yon. Okay? Yun yung pera na ihuhulog niya sa pang-10 taon na kailangan maghulog siya ng 5,500. If you get my point. Okay. So Alvin saved 5,500 at the end of 10th year. Okay, again, that this is not the total. This is the money that he will save at the 10th year na kailangan niyang i-save kasi nga yun yung pera na nadadagdagan siya every year. Okay, 'di ba nadadagdagan siya ng 500. So pagka 10 taon na, maglalagay siya or maghuhulog siya ng 5,500 ng pang 10 taon. Ibig sabihin, yung pang 9 years, 5,000. Kung nakikita niyo yung ating yung na-imagine niyo yung ating solution. Okay? Now, another. Number 2, a gardener plans to construct a trapezoidal shape structure in his garden. The longer side of trapezoid needs to start with a row of 97 bricks. Each row must be decreased by 2 bricks on each end, and the construction should stop at 25th row. Sabi. So, how many bricks does he need to buy? So, we're looking for the total bricks na kailangan. Okay, na kailangan niyang mabili. Sa first row ng ating trapezoidal shape structure, sa first row niya, okay, meron siyang 97 bricks. And then, nababawasan ito ng 2 bricks, sabi, at the end of the construction. And mag-stop siya ng pang 25th row. So, kailangan natin malaman kung ilang bricks ang ilalagay niya sa 25th row kung nag-start siya ng 97 at nagma-minus tayo ng 2 every time na nag-a-add siya ng row. No? So, first row, 97. Sa second row is 95. And so on until sa 25th row, ilan na lang yung matitirang bricks. At ang second question is, gaano karaming bricks ang kailangan niyang bilhin? Okay? Para mabigyan niya ng bricks yung trapezoidal shape na yon na mag-i-start ng 97 hanggang 25th row. If you get the point of this problem. Now, first, okay, suppose this is the brick. This is the trapezoidal structure. Okay, and meron siyang mga bricks dyan. So, the first row is 97 bricks. And then, magma-minus tayo ng negative 2. Or, magma-minus tayo ng 2 kasi every row, nag-iiba siya ng bricks. Okay? And so on. Ngayon, yung pang 25th row, ang titignan natin kung ilang bricks ang kailangan doon. Na kung saan every row, meron tayong minus 2. And then, our formula that we're going to use a sub n equals a sub 1 plus n minus 1 times d. Bakit ito yung gagamitin natin? Kasi lahat sila may common difference na 2. Okay? So, we have a sub 1 equals 97, d is negative 2, n is 25, a sub 25 is equal to, we don't know yet. Okay? Bakit pala negative 2 ang nilagay natin? Dahil nababawasan sila ng negative 2. Hindi sila nadadagdagan ng 2. Okay? Nababawasan sila. Unlike kanina dun sa 500 ni Alvin, nadadagdagan ng 500. So, we add 500 every year. That's why positive 500 yung nilagay natin. Now, dito sa problem, ang tinatanong pa is ano yung total ng bricks, di ba? So, hinahanap din natin yung SN. Okay, yung total ng numbers ng lahat ng bricks from 97, 95 hanggang dun sa 25th row. So, kailangan muna natin malaman yung 25th row. Kasi this is our first question, right? So, let's first answer the 25th row. Given this data, so the 25th row is 49. So, paano nakuha yung 49? So, we have a sub 1 plus n minus 1 times d. So, negative 2, 24 times negative 2 is negative 48 plus 97 is 49. So, sa pang 25th row, meron na lang siyang 49 bricks. Okay, so we're done with this first question. Na ngayon, ang tanong, ilang bricks lahat ang kailangan? From first row to 25th row. Okay. So, there are 49 bricks that at the 25th row. Now, compute for the total number of bricks given this the following. Okay. So, we have the formula for this one, right? We have n divide 2, quantity a sub 1 plus a sub n. Okay. So, 25 divide 2, that is... Okay. I'm sorry for this. No? This is actually over 2. Yan, lahat yan over 2. No? Ito. Over 2. If I still remember, the formula is n quantity a sub 1 plus a sub 2 all over 2. Okay. So, our a sub 1, a sub 2 is 97. A sub n, I mean. I'm sorry, it's a sub n. A sub n is 49. That's the nth row that we got. No? Okay, so, first and last row. Parang ganun siya. 97 plus 49 is 146. Okay? And then we can divide it by 2 already. Kasi itong 2 na to, dapat buo yan. Hindi siya dito. This is wrong, no? Hindi siya sa 25 lang. Sa buo yan. Kabuuan. So, 146 divided by 2 is 73. And multiplied to 25, okay, our n, which is 25. So, multiplied to 25, the answer is, ayan, 1,825. So, these are the number of bricks that a gardener needs for his garden. Okay, the 1,825 bricks. All right. Now, number 3, a piece of spoiled meat has some bacteria in it. The number of bacteria increases 5 times. So from its word increases 5 times, so I already know that this problem is a geometric sequence. Because based from our previous discussion in geometric sequence, it multiplies. It increase. There is a multiple of increase in terms of geometric sequence. So every hour, if the number of bacteria is 1,000 in the first hour, what is the total number of bacteria at the end of 5 hours? So in the first hour, it's 1,000. So what will be the number of bacteria in the last in the fifth hour? So we have the formula a sub n equals a sub 1 raised to r times r raised to n minus 1. So for the first hour, we have 1,000 bacteria. Second hour, 5 times, so we don't know. That's 5,000, right? So the question is, in the fifth hour, what will be the number of bacteria? So we have 5 times. So it has a multiples of 5. So a sub 1 equals 1,000. That's the first term. R is equal to 5. So we will just look into the formula. The formula will serve as the given. Okay? So a sub 1 R n. So n is equal to 5. Okay, because it is 5 hours at the end of 5 hours. All right. Okay, so r is the ratio, right? So we have a sub n equals what? Okay. So we have find the total bacteria after 5 hours. So this is our solution. So we have a sub 1, which is 1,000, quantity 5, which is the n, the r, and the n is 5. So 5 minus 1 is 4. 5 raised to 4 is 625, and multiply to 1,000, the answer is 6,200, 625,000. So that is our, the number of bacteria that has in a meat for about 5 hours. If it start in 1,000 and then it has a multiples of 5. So every nagmo-multiply siya ng times 5. Okay? So at the end of 5 hours, the total number of bacteria is 625,000. Alright, let's talk about the harmonic sequence. Harmonic sequence is a sequence such that the reciprocals of the term form an arithmetic sequence. Given the arithmetic sequence 5, 9, 13, 17, 21, find the first seventh term or seven terms of the corresponding harmonic sequence. So we have 5, 9, 13, 17, and 21. Completing the seven terms of the sequence, we have 5, 9, 13, 17, 21, 25, and 29. So it has a, so what do you think is the common difference? They have a common difference of 4, I think, right? So um, the number increases by 4. So we have 5, then minus plus 4, 9, plus 4, 13 until 29. So therefore, the first seventh term of the harmonic sequence is 1 over 5, 1 over 9, 1 over 13, 1 over 17, 1 over 21, 1 over 25, and 1 over 29. So, based on its definition, it is said that it is the reciprocal of the terms form an arithmetic sequence. So, it is the reciprocal of the terms, no? Okay, from here. So the reciprocal of 5 is 1 over 5 and the reciprocal of 29 is 1 over 29. Fibonacci sequence is a sequence wherein the first two terms are either both 1 or 0 and 1. And each term thereafter is obtained by adding the two preceding terms. So 12 days before Valentine's Day, Ding Dong decided to give Marian flowers according to the Fibonacci sequence. On the first day, he sent one red rose. On the second day, another one red rose. On the third day, two red roses, and so on. How many roses did Marian receive during the 8th day? Since each new term in the Fibonacci sequence can be obtained by adding its two preceding terms, then we have, okay, in day 1, we have 1. In day 2, 1 pa rin. Kasi that's what is given here. Ang inaano lang kasi dito is yung Fibonacci sequence. And yung Fibonacci sequence kasi nag-i-start siya ng 1, 1. So, on the first day, he sent one red roses. Second day is another one red roses. On the third day, nag-2 siya. Kasi after kasi ng Fibonacci, 1, 1, and then after nyan, 2. Then 2 plus 3, 1 plus 2 is 3. Then 2 plus 3 is 5. If you get my point, that's the Fibonacci sequence talaga. Ito yung Fibonacci sequence. So, it started 1, and then 1. Because 1 plus 0 is 1, right? And then 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. Until 8 day lang. So, hanggang dun lang siya. So, you can add, if maging 9 day yan, so i-add mo yung 13 and 21, which is 34. So, yun yung next term. Okay, ganun ang Fibonacci sequence. If you want to know Fibonacci, you can search for it, yung spiral progression, yung parang ano siya, yung parang snail, yung suso. Okay, meron siyang figure na ganon. Okay? So therefore, on the 8th day, Marian receives 21 roses. Okay? This is the total roses na marireceive niya. Hindi mo i-add dyan. Okay? Kasi in-add na natin sila kanina. Okay, 21 roses ang marireceive niya. Okay? So that's all about solving problems involving sequence, arithmetic sequence, geometric sequence, harmonic sequence, and Fibonacci sequence written by Sir Norman L. Santos and Ma'am Jennifer Grace Castro. With that, thank you very much for your listening.